Oh, wait, this is the same.
All right, you guys think you got it? Yeah? Let's check the answer. This was 2 years ago's FRQ question, 2023. Okay, did it represent something like this? Your curve? There you go. Okay, there is an FRQ question. I forget which number it is. Okay, but they're always going to ask you to sketch at a particular solution. Okay, so expect something like this on your FRQ AP exam. Okay.
That's all you have to do?
That's all you have to do for the first part, yes. Okay. Easy point, right? Yeah. Question. No questions? So far, so good. All right, so today we're going to go to page 11. We're going to find the general solutions using what we call separation of variables. And we're also going to find particular solutions, once again, using separation of variable. Who remembers how to integrate? Oh, page 9. Thank you. I can't count. There is a student in my second period class. I feel so bad. Yesterday we were in advisory period, and she very demandingly asked me what time do we leave the class. So out of pettiness, I didn't tell her. So I started writing all the times that we leave for third and fourth period, but I didn't put the time that we leave for second period. But I put down what time do we start third period, what time do we start and end for each class period except for second. And then she said, well, if there's 6 minutes for passing period, I can just easily calculate that. It took her 5 minutes to subtract. I'm so sorry. The time was 6. Anyway, there's more to the story, but it just reminded me that counting.
What? I didn't macroeconomics right.
She's like the Muna. She's like the Jair of my second period.
Those Muna? What?
Oh, that's crazy.
I'm always not like I'm picking on you. No, I'm so sorry. No, I always pick on Muna. Yes, it was Muna.
It was up on her.
I had it up there, and then I started teaching. I started going over some stuff. She was like, "Oh, we live at this time." I'm like, "It took you that long to subtract by 6." Anyway, there's obviously more to the story than when you see Muna ask her to subtract by 6. And then something else happened, and she said she was gonna stop smiling in my class. I was like, it's so hard to take you so angrily. She started giving me the pout, like the angry kid face. I told her she looked like my little niece when she gets mad. And I told her it's so hard to take you so seriously when you have stickers on your face. She was trying to be so mad. But anyway, obviously there's more to the story, but I don't even know how I got here. Anyway, I guess I just wanted to say the story.
Blame it on this fact.
All right, who remembers how to integrate? A little bit? Okay, that's what we're going to be doing in this lesson. Okay, it involves integration. Okay, so up until now in this unit, we've only been given the differential equations, right? We graphed slope fields. We even found if the general solutions are true, right? We verified those solutions. We've only been dealing with differential equations, but now we're going to actually undo the differential equations to find the general solution or the particular solution. The way that we're going to do this, and it might not make sense, we're going to get all the y variables on one side along with the dy, and all the x variables with the dx. Okay? First of all, if you're given as y prime, write it as dy over dx. And then we're going to separate the variables to get the y's with the dy's, the x with the dx. Well, what in the world does that mean? Let's do this problem. Okay. The first thing we're going to do, that y prime, I'm going to write it as dy over dx. It's the same thing as y prime, right? Equals to 2x over y. And like I said, we're gonna get all the y's with the dy's and all the x with the dx. So to do that, I'm gonna multiply both sides by y. And then I'm gonna multiply both sides by dx. It's like cross multiplying. I can separate these. Do I have all the y's with the dy's and all the x's with the dx? Yes. Once I have the variables with each other, then I'm gonna go in and integrate. This is gonna help us find the equation whose derivative will give us 2x over y. And notice how for the left side, we're integrating with respect to y. So what's the integral of y? What's the exponent going to be for y? Squared, very good. And what is the coefficient? 1/2 times the reciprocal of the new exponent, right? You don't have to put down plus c because we still have to integrate the other side. And what's the integral of 2x? X squared. And now we're going to put down plus c. If you can easily solve for y, solve for y. Some equations, it's just generally almost impossible to solve for y. But in this case, can we easily solve for y? And if so, what do we do first? Isolate y. So how do I isolate this y? Multiply both sides by 2. And then 2 times a constant will still give us a constant, right? You could put down 2c if you choose to, but it's still going to be a constant. Then what else do we do to solve for y? Take the square root. And every time we take the square root, what happens? Good. Later on, maybe even today, we'll see when to use a plus or when to use a minus. And this is our general solution. A general solution will have a plus c. A particular solution will not have a plus c. In a particular solution, you will also be given a coordinate point. Questions? So far, so good? So this is our first problem using separation of variable. Try the next one. Were you talking to me? What did you say? Yeah, go ahead. When you're using your time symbols, try to use a dot instead of X. When you're using times, try to use dots instead of X. Okay. They shouldn't be, they shouldn't do it, but your APA readers might think it's a variable X. There you go.
I'm sorry. I'm looking at colorful.
That's okay. That's good. Here is US. That's crazy. Most of their sweater are in Europe. I'm not trying to be disrespectful, but you know, like Canadian, he has McKinney, Adam, That's crazy.
Yeah.
Yeah, they do.
A lot. It is right.
That was a nice goal too.
Yeah, it is.
I did see the last part of it.
No, just police. Obviously, that's mine.
What about him? Did you see the game?
Yeah, he was pretty safe.
I mean, I was too, but gotta give it to Panama. They're gonna beat Panama.
Oh, yeah.
Pinch it. Just two fingers. And then drag it all the way up. There you go.
I forgot how to do this.
What is the antiderivative of cosine? Or what function gives you a derivative of cosine?
Sine.
Sine, very good.
So just sine.
Sine of what?
This is gonna be.
What is your new exponent going to be?
Is it negative?
You're gonna add by 1.
Okay, add by 1. So times the reciprocal, right?
Of the new exponent.
Okay. So that's good.
Mm-hmm.
That's gonna be 4. Oh my god, my fault.
No, you were right.
1 over 4 times 4. Right?
And then plus C. There you go. Can you solve for Y?
So for what?
Did anybody solve for Y?
Do we divide by? No?
You got divide. Did anybody solve for Y? How do you solve for Y? Meaning, how do you cancel out the sine? Do what? The inverse of sine. Very good. You do the inverse of sine.
So both of them?
No, just the inverse of sine. Just like, oh my gosh, everything is aligning to my pre-calc right now. So like this. Or arc sine, right? You can write it either or. So Y equals. The inverse of sine.
This right?
So parentheses. Everything on the other side. Everything on your right side. But simplify it.
But simplify it, right?
What's 1/4 times 4?
Right?
There you go. And then close your parentheses.
How about this?
There you go. That's your final answer.
That's it?
That's it.
Oh.
Very good. Is this what you guys got? Yeah? Any questions of how we got here?
Damn, what was the slowest?
What do I have for next week Monday? Is that still separation? A variable. It is. All right. Any questions on how to find the general solution? No questions? So far, so good? Yes?
Yo.
All right, now what about how to find particular solutions? Okay, when it's passing through a point, your final answer will no longer have plus C. So remember, general solution does have plus C. Particular solution will no longer have plus C. So we're gonna still find the general solution. We're gonna still do what we've been doing. Okay, ooh, this was a little bit more fun. What do we do? the way I like to think of it, I'm going to multiply everything by dx. I want to get rid of that fraction, that dy dx. So I'm going to write it as x squared plus 4 times dy equals to x times y dx. And then I'm going to tell myself, well, I want all the x's on the right side and all the y's on the left side. How do I get rid of the x squared to go to the other side, and how do I get rid of the y? Well, we don't want to divide by dy. We want to keep it in the numerator. So we want to keep the dy's like this and the dx like it is.
What did we say? Like,
We want to move this x squared to the other side, and we want to move this y to this other side, because we want to get all our y's with dy's and all our x with dx.
it's not useful.
Well, we are not integrating yet. What are we dividing by? Good. You're dividing both sides by x squared plus 4, and then by y. So we're going to have dy equals to x times y dx over x squared plus 4. And then we divide everything by y, right? Or multiply everything times 1 over y. Let me put the dx outside here. So you guys see what we did? Any questions? So now, are all the variables y's with the dy's and all the x variables with the dx? Yeah. So what do we do next? We integrate. Very good. So now that all the y's are with the y's, the x with the dx, we're going to integrate. What's the integral of 1 over y? Of what? ln of the absolute value of y. How do I integrate that x variable? I can't cancel out the x because of that plus 4. Adding and subtracting complicates things. No wonder Luna struggled. Oh, man.
No, she's not.
Female tiger.
It's just because I pick on her. That's it. Nothing. So how do I integrate this, y'all? Let's go down the list. Can I use anti-power rule? Bless you. Can I use u sub? I can use u sub. Okay, what would be the inside, or what would be the u? The denominator. Very good. So now what's the u? But I only want x dx, right? So I gotta get rid of that extra 2. Divide everything by 2. All right, so now this integral is going to be 1/2 1 over u du. So now what's the integral of 1 over u? ln of, very good, and I'm going to replace back for u. In this case, you don't need your absolute values anymore.
Hi, good afternoon. Could you please send Sophia to the front office for checkout?
Which Sophia?
I can't say her last name.
N or with the C?
And
N, okay, thank you.
thank you.
I'm gonna try.
Bye, Sophia. Have a great weekend. Right, we no longer need the absolute value because x squared plus 4 is already positive, but it's not wrong to still have it. But I'm not gonna put it. Bye, Sophia. I'm sorry? Not yet. Well, you're gonna use it to find the value of c. Now, great observation. I thought we don't put plus c. The final answer will not have plus c. We're gonna use those values to find what is the value of c. And you just plug in. So the y value is 2. And our x value is what? Negative 3, thank you. That's going to help us find the value of c. ln of 2 is just ln of 2. Then we get 1/2 ln of 5, right?
No.
Wow, why did I subtract them? 13, thank you. Yeah, I'm just making sure y'all are paying attention. That was it. No, I can't count, I guess. I can't subtract or add either. Jeez, Luna really just took a toll on me. Oh, God. What do we do next? Suffer. I did tell my friend about something and I forgot to tell Luna. That's what's really making me laugh.
Oh, never mind.
Now, if we subtract, right, to solve for c. Now, if you want to keep it as one term, right, I'm going to take an extra step. We can write it like this, right, because the coefficient of a natural log is the same as the exponent. Where is it? Right here, right? The coefficient is the same as the exponent. So therefore, since they're subtracting, we're going to use the quotient property and write it ln of 2 over the square root of 13. And that's the value of c. So now our particular solution is ln, let me use a different color actually. ln of the absolute value of y, which actually we no longer need the absolute value because our particular solution, the y value is already 2, so we don't need the absolute value anymore, equals to 1/2 ln of x squared plus 4 plus ln of 2 over the square root of 13. Fun! I can tell you all are having so much fun. Can we solve for y? Let's solve for y. This is fun. I'm having a lot of fun. We found the value of c, right? So now I went back, since c equals to this value, I went back to this general solution and plugged in the value of c, right? So this goes back to that. How do we solve for y? Meaning, how do we cancel out the natural log? E, raise it to the power of e. So this is the same thing as e to the power of all that, right? Can I resize? I can't resize. That's okay. E to the power of all that, right? equals, why did I do that? I swapped it. I just don't know what self-employed. Okay. Thank you for checking. I probably would have finished if I just wrote it down, huh? It's okay. How does that solve for y? Good, the natural log and the ln cancel out. Why did I write this twice? I already did have it. Oh my god. Like this, right? There we go. So the natural log and the e cancel out. So I'm gonna rewrite this right here. Okay, using my exponential properties. Since the exponents are adding, right? Since the exponents are adding, I can rewrite it as each base being multiplied, right? So times e to the power of ln of 2 over the square root of 13. Right? No.
I got lost.
Where? Do you see how we got this step? Do you see how we got here? And then we solved for c, right?
Yeah, up until you did
So now I went back. Since c equals to that, I just went back and replaced this with the value of c, right? But now I'm just going to solve for y. And to cancel out the ln, I got to do its inverse, which is e. And what I do to one side, I have to do it to the other side. You can also think of it, well, now I want to rewrite it as an exponential function, right?
Oh, so now y is like
Now y is all by itself. But now for this one right here, I'm using my exponential properties. Since the bases are adding, right, I can separate them like this, which is what I did here. But I can simplify a little bit further. Why? What does this simplify to? Anyone? Did I lose you? You can cancel them out too. The e and the ln cancel out, so you're left with the square root of x squared plus 4 times, what about the other one? You also cancel out, right? How do you still fill my space? Which in other words, y equals to 2 over, I'll just keep it as two separate terms. Square root of 13 times the square root of x squared plus 4. That's our particular solution. All right, we'll stop here. How's the math? That's it. Not much new stuff, right? Little new. Not a lot of new. You know what the thing is called?
You can have a good job.
And I'm also here if you guys get stuck with a problem. Instead of you crying in the middle of the night trying to figure out the problem, why not cry in my classroom and we can cry together? Right?
I don't know.
I have friends in class.
Me too.
Last one. I share yours.
Speaking of crying, let me finish this recording.